Alrighty, welcome back, guys. Before I start sets and Venn diagrams, I want to do a little bit on permutations from our last lesson. Um, just want to add something in. So, none of the problems we did with the permutations had numbers or digits or letters that repeated. So, I do have to show you that. Sometimes you are going to have a permutation with repetition. And what that means is that some of the letters or numbers are repeating. So you can't distinguish between a 5 and a 5. I mean, that is what it is. So let's take the lovely state of Mississippi, Mississippi. Now I learned to spell it. M-I, crooked letter, I, crooked letter, I, humpback, I. Yeah, I don't know why, but I did. So anyways, yeah. So that's today's crazy. So I want to know is how many different ways can I arrange these letters? All right, now since order matters because if you change one letter, it's spelled differently, and obviously it's not correct. So the order matters, so it's a permutation. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we would be taking 11 things, taking 11 at a time. We do that permutation, we pick up our calculator and get that answer. But we've got some letters repeating. Matter of fact, we have S's repeating, and there's 4 of them. We have I's repeating, and there's 4 of them. And then we have 2 P's repeating. So what you have to do is you have to do the 11P 11 on permutations, but then you have to divide it by 4 factorial. Remember, 4 factorial is 4 times 3 times 2 times 1. So these are the repeats on the bottom. You have to divide by the number of repeating terms. Because, again, this S is the same as this S. It's not going to change the way it is. Those are your repeats right there. Okay, and if I were to do the math on that, 11P11 divided by all that, it would come out to be 34,650. Trust me on this one. You can do it and you'll see that. All right, but I wanted to just touch base on that in case you see those somewhere where you have repeating letters or numbers or whatever. Okay, so on to today's a Venn diagram. I know you guys have seen these. Those are the circle diagrams, if you will. All right, so let's go ahead. I'm going to do a quick pause here so you don't have to watch me draw it and waste your time. All right, I'm back with my 2 little circles here. Now, we got to have some familiarity with what's going on here. Let's just call this can be just A and B. That doesn't matter. Now, that's not much of a D or a B, but let's, B, there we go. A and B. All right, now, the whole thing, this whole rectangle, if you will, that's my universe, okay? That's everything that's in the universe, okay? And the universe can be anything. Like you can describe it as whole numbers, prime number. It doesn't matter. It can be animal. It doesn't matter. Animals, people, doesn't matter. You describe it. It's going to be described to you, okay? Then A and B could be whatever. Now, so these represent B. Everything that's in B is in that circle. Everything that's in A is in that circle. Then everything that overlaps, that's in both of them. Okay? So we got to learn some things here. Obviously, that's why we're doing this. Hello. So A intersection B. Okay? That's the intersection. That's what that symbol means right there. That's intersection. Okay? That's what the two things have in common. All right? That's what they have in common. So that would be designated by this spot right here in the middle. That would be A intersect B. Anything that's in that spot right there is in both sets A and B. Okay? That's sets A and B right there. That's the intersection of set A and B. Right there. That little guy. That thing right there. That's the intersection. Okay? Alright. And then we have the union, which is, and you guys know what union is because we've done that with domain and stuff. Okay, that's the union. And that's when you combine them. That's everything together in both of them. Alright? And that would be everything that's in both circles. So it would be all of this and then all of this. So both of these. So that's the union. Alright? Now, sometimes there'll be nothing in common. There's a couple things you need to know when you have two set brackets with nothing inside. That's called the empty set. Sometimes you'll see this symbol instead of the empty set. That's called the null set. They mean the same thing. Okay, the empty set or the null set. All right. Now, a couple things we need to be familiar with. Now, I do want you guys to know that on this lesson for this day, I put a couple, at least one, maybe two documents on the lesson. If you look on the calendar, that's where everything should be. But I put some documents with these symbols and stuff in so you can understand them. First symbol we need to know is this guy. Now, sometimes you'll see it written like this. A sideways U with a line. They kind of mean the same thing. Where for us it's going to be the same thing. So when you see either one of those, that's going to mean that something is a subset. All right, and I'm going to describe that, so don't worry about it. So it's a subset. In other words, it's included in the set. Okay, that's what that means. So it means it is a subset. Sometimes it'll say, you'll see where this one's called a proper subset, like I think this one's called a proper subset. This one some kind says subset, or it's a subset and equal to, because it's got the little equal sign. Not going to get fussy about that. It just means it's included in the set. Okay? Then you got this funky looking E-shaped thing is what I call it. And that means that it is an element of or a member, if you will. It's in the set. Okay? And I know they sound kind of alike, but a member is a single thing. Alright? Now, all of those can have, both of those can have little, like, lines through. That would be not an element or not a subset of. And then this would be not an element of. So these over here, they mean not. You know, just like you see anything, a little slash through. Alright? Now, you don't see much of this next thing anymore. This little squiggly right here, like if that was in front of something like an A, that would mean not in set A. Okay. Nowadays you see the little tick mark. They call it the prime, so A prime, not A complement. And so that's what that means. That means it's not in set A. Both of those mean not in set A or A prime. That's how you would say those. All right. But what they both mean is, again, not in the set. It's often called the complement. Not like, oh, you look nice today. No, not like that. So to give you an example, let's say in the class, G was the set of girls. Well, G prime or not G would be everybody else. Okay? So everybody that's not a girl. That's what that means, okay? That's what that little symbol means, or that little prime means right there. It means not. It means a subset of. Okay? All right, moving on. All right, so let's do a little example here. Let's get two sets, set C and set D. Okay? Set C is the numbers 1, 2, 3, 4, 5. Okay? So that's set C. Set D is going to be the numbers 2, 4, 6, 8. Okay? Both of those make up our entire universe. So in other words, the only thing in our whole entire universe are those two sets. All right? That's it. That's it. So if I wanted to do a couple of the things that I brought up today, let's say we wanted C intersect D. What do set C and set D have in common? Well, if you look over there, ooh, that was that might have been the ugliest set bracket ever invented. Wow. Yowzer. Okay, so anyways, what do they have in common? What members or elements do they have in common? And you can see they have a 2 and a 4, and that's it. So the intersection of sets C and D would be 2 and 4. All right. Now if I were to do the union, that means everything in sets C and D. Well, we got 1, 2, 3, 4, 5. All right. So 1, 2, 3, 4, 5. We already got a 2. We already got the 4. We need the 6 and the 8. So that would be everything that is in both of them. That would be the union. Okay? Now, let's say I wanted not C or the complement of C. So remember, the only thing in our universe are these two sets. So everything that's not in C, well, 2's in C. 4 is not, 6 is not, 8 is not. Okay, I take that back. 4 is also, 2 is, and 4. So only 6 and 8. So the answer to this one would be 6 and 8. That would be the complement of C. So it's everything else in the universe except what's in C. And then you might get a question like this. Is 1 a member of set D? Or an element? A member, an element. And the answer is no. Okay? 1 is not in set D. All right, that's what that means. Now, if we're putting this in a little Venn diagram, I guess we should do that because, I talked about Venn diagrams. Let's see if I can do two little circles over here real quick. Probably not going to be big enough, but we'll deal with it. Okay, let's say this was C and D. So I always do, when I'm drawing a Venn diagram, I always start with what they have in common. And what they have in common is a 2 and a 4. So those go in the middle, 2, 4. Then set C, we got a 1, a 3, and a 5, 6, and an 8. And see, there's my intersection, 2, 4. My union is everything. That's how a Venn diagram works, guys. On your worksheet, you're going to have for practice on this, you're going to want to do the intersection parts first. All right. Now, the other thing we talked about was the subsets. If I have C equals, I'm going to make up a new one here, 3, 5, and 7, okay? If I wanted to list all the subsets, so everything basically that can make up a set that's part of C. Well, the empty set's always a subset of everything. Not a zero, moron. The empty set, which means it's empty. Dummy, which means there's nothing in there. Okay, so just the empty set. Okay, so that's a subset. And then every single member is also a subset, as well as the set itself. I know it sounds redundant, but that is. See, that's where the little equal sign comes in under the symbol. These are all subsets. You remember the symbol for this was this or this? Subsets. And then actually every single member by itself is a subset. Even though it's a single member, it's a subset. And then any way you can put them together. So 3, 5, 5, 7, and what? 3, 7? Yeah, so that's a lot. And it's 1, 2, 3, 4, 5, 6, 7, 8. So yeah, those are all subsets. All right. Let's do one more and we'll call it a day. Let's get our universe here. We'll do set A is 1 and 2. Set B, 1, 2, 3, 4, 5. Oops. All right, so there's my universe. Okay. So let's see. Let's just practice one more time. A intersect B. What do they both have in common? 1 and 2. So it's actually all of set A. Okay, A union B. Some of you already noticed what's going on here. That would actually be all of B because 1 and 2 are in there. A is a subset of B. So they're all in there. All right. Now, what if I wanted not A or A prime or the complement of A? Well, what's in the universe that's not in A? 3, 4, 5. Oh, whoa, whoa, whoa. See, you didn't tell me you couldn't see it. So let me do this over. So not A or the complement of A. That would be everything that's not in A, that's in my universe, which would be 3, 4, and 5. Okay. What about not B? What about the B prime or the complement of B? What's in my universe but not in B? Yeah, everything's in B. So the answer to this would be my empty set. Okay? All right, guys, there's a worksheet on the lesson. Okay, that's your practice. The answers are up there. Remember, you guys have the 3 graded assignments this week. You don't have to wait till Sunday. Hopefully we're getting caught up, guys. I'm getting a little nervous about some of you. So, and probably the people I'm nervous about won't hear this because a lot of you aren't watching the videos. And again, if you're one of those people not watching the videos, you're not hearing this either. Till next time, guys. Bye-bye.